Elliot is a runner training to compete in the Boston Marathon. He looks up the winning times for the Boston Marathon over the past 20 years to see the performances required for victory. Here are the winning times. Elliot notices that the winning times are around 2 hours and 10 minutes. A marathon is 26.2 miles. 2 hours and 10 minutes works out to a per mile pace of about 5 minutes per mile. Try to run just 1 mile in 5 minutes. It's not easy. But Elliot has been training, so maybe he can perform at a high level in Boston. How can we better visualize this data? A box and whisker plot is a great tool for seeing the shape, center, and spread of these marathon times. To construct it, we reorganize the data in order. We organize the times from smallest to largest. We'll leave out the 2 hours in each time and convert the seconds to decimal minutes. Now we have a list of the minutes above 2 hours for each winner. We create our plot by scaling the y-axis from below the minimum 3 to above the maximum 14.2. So just to be safe, let's scale from 2 minutes all the way to 15 minutes. Our minimum is 3 minutes. We'll mark that with a horizontal line. Our maximum is 14.2 minutes. That shows us the spread of the data. Now let's find the median. That's the middle number. Since there are 20 winning times here, there is no middle in the list. We'll have to average the 10th and the 11th numbers. That's 9.75 minutes. We'll mark the median with a horizontal line. To see the shape of the data, let's find the median of the top 10 times. We average the 5th and 6th time for what we will call a first quartile of 8.2 minutes. It's called the first quartile because 25% of the times will be faster than 8.2 minutes. Those guys were pretty elite. Let's mark Q1 with a horizontal line. Now let's find the third quartile. We find the median of the second half of the data, the bottom 10. So we average the 15th and 16th number to get a third quartile of 10.6 minutes. Anyone behind that time was in the last 25% of the runners. They still won though, just with a slower time. Let's mark Q3 with a horizontal line. To finish the plot, we create a rectangle joining Q1 and Q3. That's our box. Then we draw vertical lines from the box to the min and the max. Those are the whiskers. The values between Q1 and Q3 represent the middle 50% of the data, clustered around the median. And it is tightly clustered here, isn't it? The middle 50% takes up a small portion of the graph, while the remaining 50% takes up a lot of the graph. The times of the middle 50% were very close to the median. Runners that were outside the middle 50% sometimes ran much faster or much slower. With a box and whisker plot, we can visualize the max, the min, the median, and Q1 and Q3, the borders of that middle 50% of Boston Marathon winners. Elliot makes a plan to run 2 hours and 8 minutes in Boston. What do you think his chances of winning are? Elliot does well in Boston with a time of 2 hours and 7.5 minutes. But he comes in 5th place. He's thinking about running in the New York City Marathon. Here's the box plot for the winning times for New York over the past 20 years. Can you see any differences between Boston and New York? The median is faster in New York, at 9.2 minutes. And the winning times are more tightly clustered around the median. Q1 and Q3 are closer together. The fastest winning time, the minimum, is only 5.1 minutes above 2 hours, and the max is only 11 minutes above 2 hours. Elliot thinks that if he finishes in 2 hours and 7.5 minutes, his chances are pretty good in New York. What do you think? Q1 is 2 hours and 8.2 minutes, and anything better than that is in the top 25% of winning times. Elliot's chances do seem pretty good. Remember, a box and whisker plot is a great way to visualize 5 major components of a data set: the min, the max, the median, the first quartile, and the third quartile. Box and Whisker plots are also great for comparing data. Math students and elite marathoners can use box and Whisker plots to understand data and be their best.